Hola, hola, ¿cómo están? Soy Matías, esto es Espacio para Todos. Bienvenidos. Hoy tenemos el lanzamiento de un Falcon 9 con carga a la estación espacial. Esta es la misión CRS-34. CRS significa Commercial Resupply Service, número 34. Entonces la misión 34, esta nave en especial ya ha sido reutilizada. Estamos ahorita a 17 minutos. Vamos a hablar un poco sobre el cohete. Este es el tercer intento de lanzamiento para esta misión. La primera ni siquiera se llegó a llenar el cohete, la segunda se llegó a T-30 segundos. El vehículo es un Falcon 9, bloque 5, tiene 70 metros de altura con la cápsula Dragón encima. Tiene un diámetro de 3.7 metros, una masa total al momento de despegue de 549.054 kilogramos. Esos son 550 toneladas. Esa masa se divide de la siguiente forma. La primera etapa, que pesa aproximadamente 433.000 kilos, llena de combustible. Y la segunda etapa, unos 111.000 kilos, obviamente con combustibles. Sí, la diferencia es la cápsula, que la una tiene también la cápsula arriba. Los propelentes que se usan para esta cápsula son los mismos que siempre se usan para las misiones de Falcon 9, que es queroseno refinado. Es el RP1, es queroseno de grado aeroespacial, enfriado a menos 7 grados Celsius para poder densificar y así entra más combustible dentro del tanque. El oxígeno líquido o el OX también es súper enfriado a menos 207 grados Celsius, casi al punto de congelación. Sí, en la primera etapa se va, como les decía, va a 287 kilogramos de LOX, de oxígeno líquido y 123.000 kilos de RP1, de RP1. La segunda etapa son 75.000 kilos de LOX y 32 kilos de RP1. A T-20 minutos, estamos ahorita a T-15 minutos. Vamos a hablar los motores. Bueno, ahorita no estamos, vamos a aprovechar bueno, esta es la etapa, este es el Dragon, que es lo que va arriba. Esta cápsula es la cápsula C-209, es su sexto vuelo. Voló la misión CRS-22, CRS-24, CRS-27, CRS-30 y CRS-32. Recordemos que estas cápsulas son reutilizables, entonces cuando llegan a la estación, después de un mes regresan llenas de ciencia y de cosas que ya no necesitan en la estación. Sí, esta es la primera vez que la cápsula vuela por sexta vez. Dentro de la cápsula hay 200, casi 3.000 kilos de carga. Eso es carga presurizada que va dentro de la cápsula y carga no presurizada que va en la parte baja, que es donde están los paneles solares y los radiadores. De ahí, bueno, ahí está la primera etapa, nos están mostrando. La primera etapa son 50 metros aproximadamente. Tiene 9 motores y esta etapa como tal ha volado 5 veces las distintas misiones. Como les decía, también la cápsula ha volado, esta sería la sexta vez. La primera etapa va a regresar y va a aterrizar ahí, nos está mostrando en la toma, en el landing zone 40.
continue to monitor the fueling of the rocket. Well, continuing scientific discovery aboard the International Space Station is enabled by missions like today. And as you mentioned, Dragon is carrying over 6,000 pounds of cargo, including critical science hardware and samples. The science aboard Dragon represents months and in some cases years of preparation by dedicated scientists and engineers. And here are some of the highlights of what's inside Dragon today. The Odyssey research investigation evaluates how well Earth-based microgravity simulators recreate space conditions. Researchers will examine bacterial behavior in space and compare the results to experiments conducted in microgravity simulators on Earth. Another investigation we're looking forward to learning more about is STORY. The story behind STORY is an instrument that monitors charged particles in orbit around the Earth. These particles respond to space weather and can impact human assets like power grids and satellites. STORY could help researchers gain knowledge to better predict and respond to these changes. Laplace studies the movement and collision of dust particles in microgravity to understand particle motion in space and other atmospheres. Researchers hope to learn more about Earth's origins and provide fundamental understanding of how these planets in our solar system came to be in existence. The green bone investigation observes how bone cells grow and develop on a bone scaffold that is actually made from wood, and it'll be in space. Microgravity results could help researchers improve products that treat fragile bone conditions such as osteoporosis. The SPARK investigation is how red blood cells and the spleen change in space. Researchers will observe human samples and imagery taken before, during, and after spaceflight to identify ways to protect astronaut health during long-duration space missions. And these are just some of the incredible research flying to the International Space Station aboard today's mission, and you can find out more at nasa.gov/ISS-science. Now, in addition to this incredible research, this mission is carrying several bulk overwrap bags, or here at NASA we call them bobs, delivering a mix of standard and crew-specific, shelf-stable, and fresh food items to support crew health and morale on orbit. Now, these items include standard and crew-requested items that include taco kits, chocolate, and cereals, along with fresh foods such as apples, tomatoes, and baby carrots. Now, as we approach T-minus 11 minutes left in the countdown, keeping an eye on the fueling, we heard earlier that the Stage 2 RP-1...
Esta carga está llevando, como nos comentaban, comida que ha solicitado la tripulación. En este caso han pedido hasta tacos. Esto es para mantener la moral en alto de la tripulación, ya que estar dentro de una cápsula durante meses y meses puede ser, puede causarte problemas mentales. Todo está bien a T-10 minutos.
Through the Merlin engine pumps, chilling those engines down through the start sequence. We do that because the super chilled and densified liquid oxygen is really, really cold. And we use that process to bring all of the engine hardware down to a cooler temperature before flowing all of the LOX and RP-1 into it during flight. Engine chill specifically helps to prevent thermal shock and ensures nominal engine performance on liftoff and all the way through ascent. We're going to keep listening in for all of these updates from Mission Control, but in the meantime, let's check back in with NASA again. Joseph?
Thank you, Ronnie. Greatly appreciate it. And yes, certainly looking forward to it as we're now approaching 9.5 minutes until liftoff of NASA SpaceX 34th Commercial Resupply Services mission heading towards the International Space Station, which is a perfect opportunity to introduce you to the Expedition 74 crew. And we mentioned earlier that includes NASA astronauts Chris Williams, Jessica Meir, and Jack Hathaway. They're also joined alongside by Roscosmos cosmonauts Sergei Kutsverchkov, who is the station commander, Sergei Mikheyev, and Andrei Fedyaev. Also joining him on board the International Space Station is ESA astronaut, or European Space Agency astronaut, Sophie Adno. Now on tap for docking as the Dragon spacecraft makes its way closer and closer to station. It will be Hathaway of NASA and ADNO of ESA that will be monitoring the Dragon spacecraft as it gets closer and closer to the orbiting laboratory. Now for Chris Williams, Sergei Kudryashkov, and Sergei Mikheyev, they would arrive on station last November on Thanksgiving, November 27th, and are now entering or moving through their 169th day in space. And for Jessica Meir, Jack Hathaway, Sophie Adno, and Andrei Fedyaev, they would launch back on February 13th aboard Dragon Freedom as a part of Crew 12 and are moving through their 91st day in space. Well, as we get closer and closer to engine tilt, taking a look at the updated fueling, it looks like the stage 1 RP1 load is about to wrap up, about 90% of the way there for the liquid oxygen of the first stage, and about 60% for the stage 2 liquid oxygen. But for now, as we get closer and closer to, as Ronnie mentioned, engine chill, and we continue to progress in the countdown, now reaching 8 minutes to go until liftoff. Back to Ronnie Foreman in Hawthorne.
So as I mentioned earlier, now we are standing by for some of those key callouts and visual indicators that we are getting closer to our T0 time. The next major visual milestone we're going to get is actually about the transporter erector, which is the tall truss structure standing to the side of Falcon 9. You've got a view of it there on the right-hand side of your screen, and again, we have LZ-40 over there on the left. Those two clamp arms up at the base of stage 2 are used to stabilize Falcon 9 during our propellant loading, which again began at about T-minus 35 minutes. The TE, which again is that large trussed piece on the right-hand side, is used both to roll Falcon 9 out to the pad and then raise it into the vertical launch position. It stays connected through the final seconds of the launch countdown. We will see those stabilizing clamp arms open up around the second stage.
Engine chill has started.
At about T-minus 4 minutes and 17 seconds. But there we did just get that announcement from Mission Control that engine chill has begun. Fun fact, the super chilled liquid oxygen on board Falcon 9 is at about 300 degrees below zero. Everything is still looking good for an on-time liftoff just under 6.5 minutes from now, and we are still tracking 95%.
Stage 1 RP1 load is complete.
95% favorable launch weather conditions at our T0 time, and we did just hear the confirmation that RP1, or Rocket Propellant 1, has been fully loaded onto stage 1. Right now, we are just about 2 minutes away from those clamp arms opening up around the second stage. As I mentioned before, those clamps help to stabilize the rocket during fueling. They also prevent movement in high winds. But once they're open, the rocket will be fully free at the top. Then we will also hear that key call out from Mission Control that our tanks are pressurizing for strong back retract, which is one of the things that helps Falcon 9 stand freely on the pad. When we do see those clamp arms start to open up, that'll take about 15 seconds for them to fully move away from Falcon 9, and then our strong back will also retract slightly. At our liftoff time, though, the strong back will kick back a full 45 degrees away from Falcon 9, enabling it to clear the launch pad.
Falcon 9 tanks are pressing for the start of strong back retract.
There's that confirmation that Falcon 9 is getting ready for strong back retraction. A really great view of those hypersonic grid fins at the base of the inner stage on your screen right now. Those are the primary mechanical...
Dragon is in terminal count and is on internal power.
There's confirmation that our system is on internal power.
Lower has started.
And we are heading into the final 5 minutes before liftoff. There you can see those clamp arms starting to open up. And we should see some movement from the TE shortly.
Now, a little more than 3 minutes to go before liftoff. We're wishing to report the range is also green to support today's launch. Now, if for some reason we do not launch today, we do have a backup opportunity. That'll be tomorrow, Saturday, May 16th at 5:43 p.m. Eastern Time. But right now, all systems tracking well as we continue to monitor the final progress of fueling and getting ready for liftoff.
So we're going to continue listening in over the countdown nets. And the next thing we're expecting is stage 1 LOX load complete.
Stage 1 LOX load is complete.
Right on schedule. The second stage should now finish up about a minute after that. Our tanks are also pressurized using helium. That helium is chilled too, so that it stays compatible with the cryogenic plumbing on board Falcon 9. During flight, that helium pressurization helps force propellant into the engines as the tanks empty. In these last few minutes, Falcon 9 is performing final health checks on its primary communications, avionics, and propulsion systems in preparation for flight. We may hear some more callouts that the engines are sufficiently chilled as we get a little closer to liftoff. And again, we are standing by for another fuel loading completion call in about 20 seconds.
And around this time, the second stage thrust vector control actuators are being tested and checked out. And this is when SpaceX moves the nozzle ever so slightly to make sure that guidance hardware is acceptable for flight. In about 2 minutes, at the time of launch, the International Space Station will be flying some 260 miles off the southern coast of Australia as we hear that stage 2 LOX load is complete and Falcon 9 is now fully fueled. The first and second stages are now fully loaded
Dragon
with over
is an
1 million
auto-idle.
pounds of rocket-grade kerosene. Is now Dragon moving into auto-idle. Coming up on a minute and a half left in the countdown. Now auto-idle puts the rocket in a state where the flight computers can understand before it takes off.
Now we are standing by for the T-minus 60-second callout that Falcon 9 has entered startup mode. At that point, the rocket's onboard flight computers will have taken over. From there on out, the countdown will be fully autonomous.
Falcon 9 has entered startup.
There's
Dragon is in countdown.
confirmation of startup mode for Falcon 9 and countdown for Dragon. Our last milestone here is that our launch director calls go for liftoff.
LD, go for launch.
There we have it. Just inside of T-minus 2 seconds, the 9 Merlin 1D engines on the Falcon 9 first stage will ignite. Once they're at full power, Falcon 9 will lift off the pad and begin its climb to orbit.
T-minus 30 seconds.
Listen in for these final 30 seconds.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Ignition and liftoff. Go Falcon, go Dragon, and go CRS-34.
And liftoff. NASA's SpaceX-34 commercial resupply services mission carrying over 6,500 pounds of cargo and supplies is on its way to the International Space Station.
Everything is looking good on board Falcon 9 and with our Dragon spacecraft. We heard those callouts from mission control that the rocket is pitching downrange and that all 9
Power
Merlin
and telemetry nominal.
engines continue to perform well. We're just about to throttle down the engines to prepare for max Q, the point of maximum aerodynamic pressure during ascent. Max Q happens when the combination of speed
Falcon 9 is supersonic.
and air pressure put the greatest stress on the vehicle. And with that call out from mission control, we know that Falcon 9 is moving faster than the speed of sound.
Max Q.
There's that call out for max Q. Now, coming up, there are going to be several major events that happen back to back really quickly. Main engine cutoff, stage separation, first stage flip, second engine start, and boost back burn start. Main engine cutoff will likely be called out as MECO. That's when all 9 engines on the first stage shut down. That'll be followed by stage
MVAC chill.
There's that call out for MVAC chill on board the second stage. Of course, before we can start the second stage, we do have to separate those 2 stages. The first and second stage will be separated and pushed apart from one another when we hear the call out for stage sep. Then the first stage will flip around using small thrusters so it can head back to Earth. A few seconds later, we'll light that second stage MVAC engine and continue pushing Dragon to orbit. After all of that is done, the first stage will perform its boost back burn to steer itself back toward the landing site.
Main engine cutoff.
Stage separation confirmed.
MVAC startup.
Back startup.
Great views on your screen there as you heard and hopefully saw all of those key events taking place. Main engine cutoff, stage separation, stage 1 flip, which is happening on the left-hand side of your screen, second engine start on the right-hand side of your screen, and the beginning of our boost back burn. Now, coming up shortly, we should hear the call out for completion of the boost back burn on the first stage. This burn helps to steer the booster back toward the landing site and is the first of 3 burns the first stage performs on its return to LZ-40 at Cape Canaveral Space Force Station. We are expecting that call out in just about 5 seconds.
Stage 1 boost back shutdown.
And once again, thank you for joining us as you continue to follow along with NASA's SpaceX 34th Commercial Resupply Services mission. Now 3 minutes and a little more than a half into today's flight. Takes about 9.5 minutes to get into orbit and all set as Dragon on the right-hand side with that Merlin MVAC engine on the right. Continue its chase to the orbiting laboratory, and there you can see that stage 1 making its return back to Earth on the left-hand side. We had an on-time liftoff at 6:05 p.m. Eastern Time from Space Launch Complex 40 at Cape Canaveral Space Force Station. Now, in order to make the left side, stage 1, make its return back to Earth, a couple things have to happen. 2 more burns to execute. The entry burn, where 3 of the Merlin engines will reignite, and this helps slow the stage down as it re-enters the upper part of Earth's atmosphere. And following the entry burn, the booster will go through its landing burn. And this is a single engine burn that brings the vehicle speed down rapidly in order to land back on Earth. And we should be hearing those call outs for that entry burn in just a couple of moments from now.
That's right, Joseph. We are standing by for our entry burn, which we're expecting to begin at about T plus 6 minutes and 10 seconds. Now, during that entry burn, Falcon 9 is decelerating by firing its Merlin engines, but the vehicle is still moving really fast. This causes it to fly through Merlin's exhaust gases, which are also known as the rocket's plume. That deposits a layer of soot on the vehicle's surface, which is why our flight-proven rockets look the way that they do. The soot comes from the carbon-based fuel that Falcon 9 uses, and which, with each flight, that soot builds up a little more on the outside of the vehicle. We also heard that call out from Mission Control just a few moments ago that both vehicles are on nominal trajectories. You can follow the trajectories along at home in the bottom corners of your screen. We have stage 1 on the left and stage 2 on the right.
Now 5.5 minutes into flight. There's still a few more moments to go as we continue to follow along the path of NASA's SpaceX CRS 34th Commercial Resupply Services mission. And there you can see a great view of stage 1 on the left-hand side. The grid fins that Ronnie brought up earlier in the broadcast just ahead of launch. Falcon 9 is equipped with 4 hypersonic grid fins, which are positioned near the top of the first stage and are used for steering as it returns to Earth, as you heard the start of that entry burn for the first stage. And those grid fins are a critical part of Falcon 9's reusability system. So entry burn just completed as it's shut down. Now we'll look for that landing burn as it continues to make its return back to Earth, and it will begin its descent to landing zone 40 today. And on the right-hand side, continuing to track the path of the second stage, in which the Dragon cargo spacecraft on top of that second stage, making its way into orbit. Now 6.5 minutes into today's flight. Now again, moments away from entry burn, we should see the stage 1 light back up as it will rapidly decelerate in preparation for landing at landing zone 40.
Stage 1 FTS safe.
And milestones continuing to check off for the stage 1 as it makes its return back to Earth. And we'll keep an ear out for that entry burn, startup and entry burn shutdown.
Stage 1 landing burn.
We should get some great visuals off the... So landing burn now underway, and that's the single engine that slows down stage 1 rapidly ahead of touching down back on Earth off the Florida coastline.
Stage 1 landing confirmed.
And great visualizations there as stage 1 has successfully returned back to landing zone 40. That's now 7.5 minutes into today's flight. We still have about a minute to go, a little less than that for stage 2.
And
there you can follow
heard my
along the
colleagues
pathway
behind
stage
me.
1.
That is another
Its journey has
successful
complete.
landing of our Falcon 9 rocket. This was the 6th launch and landing for this first stage. Now, coming up in just over 30 seconds, we should hear a call out for second engine cutoff 1, or SECO 1, which is when the MVAC engine on board the second stage shuts down. That'll conclude the roughly 6-minute burn by this engine needed to get Dragon into the proper orbit to align with the International Space Station.
Stage 2 FTS safe.
Stage 2 terminal guidance.
Just about 10 seconds until we should hear that SECO 1 call.
MVAC shutdown.
And then there's confirmation of MVAC shutdown on board our second stage. Now we are just standing by for confirmation of a good orbital insertion.
Stage 2 nominal orbit insertion.
And we have confirmation there of a good orbit from Mission Control. The stage 2 vehicle is now in coasting with Dragon